Welcome back. For a function f of x, the derivative of f at x, denoted by f prime of x, is the limit as h goes to 0 of f of x plus h minus f of x divided by h, and this is provided that the limit exists. If the we say that f is differentiable at x if f prime of x exists. That is, if this limit is defined. If f prime of x exists for each x in the open interval from a to b, then we say that f is differentiable on this interval or over this interval. Now, recall, f prime of a, is the slope of the tangent line to the graph of f at the point a f of a, and we also saw that f prime of x is the instantaneous rate of change of f with respect to change in x. And also recall that okay, so let's say we have a bug or a particle moving on a straight line. Let's say it is moving on the number line, and we have a function f that tells us the position of the bug at time. So f of x is the position of the bug at time x, let's say. So then, here, let's say f of a is this, and f of a plus h is this. So these are the positions of the bug at time a and at time a plus h. So then the average velocity of this bug would be f of a plus h minus f of a over h. So that's the average velocity of the bug over the period of time from a to a plus h. And so then if I take the derivative, that is, if I take the limit of this as h goes to 0, then I get the derivative of f at a, and that's the instantaneous velocity of the moving object at time a. So if f of a is the position function of a moving object along a line at time a, then its velocity at time a is given by the derivative of f at a. Okay, so let's do an example. Let's say f of x is 5x minus x squared, and we want to find the derivative of f let's find the derivative of f first. So we know that the derivative of f at x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And we're going to show that this limit is equal to 5 minus 2x. So let's check that. So here is the function. So what is f of x plus h? Well, that will be 5 times x plus h minus x plus h squared, and minus f of x is that. And then we expand here, we multiply out here, and then we simplify. And so here we get a 5x plus 5h minus, if you expand here, you get x squared plus 2xh plus h squared, and then you are subtracting, so this is what you get, minus 5x plus x squared. And notice we can cancel out 5x, we can cancel out x squared, and then we are left with 5h minus 2xh minus h squared over h. And then we take the limit. of this quantity where I'm factoring out h from the numerator. If I do that, then I can cancel out the h in the denominator, and so because h goes to 0, then I'm left with 5 minus 2x. So what we have got is that the derivative of this function at x is equal to 5 minus 2x. So let's say I want to find the equation of the tangent line to the graph of this function at the point where x is 3. Well, we have just, okay, first of all, at the point 3, so we need to know the y coordinate corresponding to x is equal to 3. So when x is 3, we get 15 minus 9, which is 6. So we want to find the equation of the tangent line to the graph of the function at the point 3 comma x. Now f prime of x is 5 minus 2x that we calculated in the previous slide. And so the derivative of f evaluated at 3 then would be the slope. So the slope would be f prime of 3, which is equal to 5 minus 2 times 3. So here is the slope, f prime of x. So f prime of 3 would be 5 minus 2 times 3, and that's going to be equal to negative 1. So the slope of the tangent line to the graph of this function at the point 3, 6 is negative 1. So what's the equation of the tangent line at this point 3 comma 6 right here? Well, we know the slope is negative 1. We know the point, so let's apply the point slope formula for a line. So it is y minus y1 is equal to m times x minus x1. x1, y1 is a particular point on the line. M is the slope. xy is an arbitrary point on the line. So replace y1 by 6, replace x1 by 3. We get y minus 6 is equal to minus 1 times x minus 3. And then we simplify this and write it in the slope-intercept formula, and we get y is equal to negative x plus 9, and that is the equation of the tangent line. Okay, so I am gonna stop the video here. In the next video, we will be looking at more examples.